We're going to talk about exponential decay today. We talked about growth the other day. Now we are still using our exponential formula, A being what? A is always our initial value. I spelled it wrong, I think, in the other video. Okay? Our initial value. And B being the growth or decay rate, right? So it's either growth or decay rate. Now, in this case, decay deals with B when it's between 0 and 1. Okay, anything greater than 1 will be growing. Anything between 0 and 1 will be decreasing in size. Okay, an exponential decrease. So, let's arbitrarily make something up. Let's say that we have a building, and it just so happens to decay at a rate of... Actually, let's do a simpler one. We'll say it's an amount. It's amount of cells sometimes. So we have an amount of cells. Let's say there is 5,000 cells in a culture. And they happen to be decaying rather than multiplying. Okay? So they're decaying at a rate of 5%. We need to create a formula that images or makes this decay rate. So, first of all, our initial value A is going to be 5,000. So we're replacing A with the number 5,000. I want you to think of this part of the formula, 1 subtract the percentage decrease. Think of it like we're taking away from 100%. So we have to turn 5% into a decimal value, and how do we do that? We divide by 100, which gives us 0.05, which means we'll be subtracting by 0.05 to the power of x. So we're going to simplify that there. Y is equal to 5,000 multiplied by 0.95. And think of that kind of like as a percentage, right? If we were decreasing by 5%, and we'll say it's 5%, I didn't give it a time frame, that's actually very important that we do, 5% per day. Okay? Think of it like it's saying that after every day, 95% of what was originally there is left. Okay, so we've lost 5% every single time. So let's find out how many cells will be left after a week. Now, because our decay rate is per day, we have to convert our weeks into days. How many days in a week? 7. So really, we're looking after 7 days. So that means our x value will be the number 7 in this case. So y is equal to 5,000 times 0.95 to the power of 7. Okay. And that's going to give us a value. Let me get a calculator out. So we can probably do this all in one step on our calculator. 0.95 to the power of 7 is equal to. Then I multiply that number by 5,000. Just as a side note, this is roughly 69, 70%. So really, we're going to have almost 70% left of 5,000. So 3,491. 3,491 are the number of cells left in that culture after 7 days or a week. Okay? And this can continue. Now remember, because we're decreasing by percentage, we'll never actually hit 0. It will just be a percentage decrease. We might only have a percentage of one cell, but we'll never get to a value of 0, which is very important for what we're doing here. Remember, there is a horizontal asymptote on our x value. Here's a second example. Termites are attacking your house. You want to know how long it will take for your house to only have a quarter of the material you started with? Your house is decaying at a 6% rate per day. Create an exponential formula and solve. So, you know our formula is going to deal with y is equal to a being our initial value, b being our decay rate to the power of x, x being the number of days because our decay rate is measured in days. Okay? Our problem is a is kind of unknown at the problem. We don't know what our initial value is. But we know that our y, in this case, will be a quarter of what a is. So, we can actually put any value we want here. For instance, to make it simple, let's say we put a as 100. Okay, we have 100% of the house. Think of it like that. to have a quarter of the house left, what percentage would we have? So our y in that case will be 25. If you wanted, you could have made a the value of 4 and y the value of 1, 1 being a quarter of 4. You could choose any values, but it's easiest to see it as a percentage. So let's put it that way. Our y value is now 25. Our a value is 100. Our decay rate is the other thing we need to find out. Now remember, it is 1 subtract the percentage decrease, which is 0.06. We turn 6 into a decimal. So we get 25 is equal to 100. 1 subtract 0.06 to the power of x. What is that going to give us in our brackets there? 94. Okay, so think of it like per day, we're only left with 94% of what we had originally. Now, because we don't talk about logarithms in this course, we have to do a trial and error for x. Okay? Now, we can simplify this a little. Okay? And what we can do is I can bring 100 over if I like and divide. So 25 divided by 100 will give us a quarter, or 0.25, is equal to 0.94 to the power of x. So we're going to plug values in for x to get an answer that is approximately equal to 0.25. So, because we don't know logs, we're going to use a bit of trial and error. Let's use some educated guessing here. We assume it's not going to be after 1 day. Probably not even after 2 or 3. I'm going to start at a value of something like 5 days. So when x is 5, we'll plug it in. So 0.94, whoops, wrong button. 0.94 to the power of 5. 73%. We're way too high. There's still about 73% of the house left. So let's jump up a couple. Let's try 10 days. Okay? 0.94 to the power of 10. 53%. We're still really high. Let's jump up to 15 days. 0.94 to the power of 15. 39. Still. 22 is that we're going with? Okay. Let's try 22 here. 0.94 to the power of 22. 25. Now, it's technically a little higher. It's 25.6% or 0.256, which means when you go to answer this, 23 will be something less. Anyone know what 23 is by chance? 0.24. Excellent. So, I would like you to answer these questions this way. Between 22 and 23 days is when we will only have a quarter of the material left. Quarter of material left. Okay? So, we've solved a straightforward question and a question where they give us an answer and we have to find a timeline.